Hi, in this video, we're going to talk about this cool property called CPCTC. And it's the idea of once we have proven two triangles incongruent, we automatically get the other three pairs of parts congruent because we have congruent triangles. So here's a proof. So what does this mean? Uh, Here's a proof that I've done already. So I've shown that these two triangles are congruent. But because I showed that these two triangles are congruent, I get everything else about the triangles. Even though I only marked three sides, I'm able to tack on the idea that E and L are congruent according to this idea of CPCTC. And what this stands for is this, that corresponding parts of congruent triangles are congruent. So CPCTC says that these corresponding parts of these congruent triangles have to be congruent. E and L are both those first parts, so those two have to be congruent, since I've taken the time to prove these triangles congruent. All right, so let's try it out. In this example, they didn't mark my diagram up. Ugh. Well, P and M are congruent. So I'm going to mark them congruent because I couldn't be bothered to do it. So P and M are congruent. That was just given to me. Then we also know that C is the midpoint of PM. That gives me that BC and EC have to be congruent. So I'm looking pretty good. I've got an angle and a side. I need a little more information. Oh, I got my good friend vertical angles. That gives me angle, angle, side. I'll give them two ticks because they're different than the blue. So that's angle, angle, side. I should be able to prove these two triangles congruent. But I got to fill in all my reasonings and stuff. So let's see. We already got that given. BC is congruent to EC. We got that from our definition of midpoint. Then we got this other angle right here, so we'll call that PCB, why not? And then ECM, thanks to vertical angles. Okay, great. So that makes our two triangles congruent. So I'm going to go by the angle, angle, side to make my congruent statement. So triangle PCB, that's got to be congruent. Go by angle, angle, side, MCE. So if I look at, I went angle, angle, side, PCB, PCB, angle, angle, side, MCE, MCE. Now, since I've done all of that work, then I get stuff for free. That's what's happening down here. That's that free thing I get by CPCTC. That after you do that triangle congruent statement, you can just kind of say this and you get whatever the heck that is. BP, this side right here, has to be congruent to EM because they're on the corresponding sides of the triangle. And also, BP is the first and last letters, M and E first and last letters in our triangle congruent statement. So that's done. All right, this one they were kind enough to label my diagram, so I know that this is congruent. So BLE and ULE. So these angles are congruent to each other. That was just given at the beginning of our problem. They also said that these two are congruent to each other. Okay, that's another thing that was just given. Well, they didn't write given, but I'm going to write given because I want to have a reason for each one of my things. And then we just need one more part. Ooh, I've got my good friend, the reflexive property. We can say that EL is congruent to itself thanks to the reflexive property. All right. Well, based on that, it seems we have a side angle side on our hands. So side angle side, that is one of my options. So I'm going to circle it, and I got to write my triangle congruence statement. I'm going to go with the 1, then the side, and then the 2, or just 1, 2, and blank. So that's triangle LEB is congruent to triangle LEU. Now that I've taken the time to write that congruent statement, then I get stuff for free. I get stuff for free thanks to CPCTC. If you haven't noticed, this pair of parts 4, it's always the CPCTC. This is telling me that BL and UL are congruent. So this side is congruent to that side thanks to CPCTC. Now, in this problem, we've got our same setup of given and whatever, but we're actually going to use it to prove this theorem that in an isosceles triangle, if the vertex angle is bisected, then the base angles are congruent. So we've got an isosceles triangle. We're going to bisect this angle up top here, and we're going to prove that these two angles have to be congruent. So if we do our same stuff, this is congruent to each other. So that's already marked on our diagram. Somebody was too lazy to mark that IG bisects sin. So IG is bisecting this angle up top. So we can say that these two angles are congruent. So that's looking pretty good. Do we know anything else as congruent? Yeah, we know that this side is congruent to itself. Thank you, reflexive property. You're so helpful. So sig is congruent to nig. So that is the definition of bisect. That gave us these two angles congruent to each other. We can also say that IG is congruent to IG. IG is congruent to IG. That is our reflexive property. All right, and based on that situation, we've got a side angle side. Okay, side angle side. Thank you very much. I can say that these two triangles, the one on this side and the one on this side, have to be congruent inside of the big triangle. So that's SIG. That has to be congruent to, let's see, I did the blue side first. So NIG. Okay. So we did the vertex angle being bisected. We had an isosceles triangle. And we've just shown that those two triangles are congruent. And because of that, the base angles are congruent. S and N are our base angles, which are the ones right down here. So those two have to be congruent thanks to CPCTC. So we just proved that statement as true up top. Let's do another one proving a theorem. So in a parallelogram, if a pair of opposite angles are congruent, then the opposite sides are congruent. So we've got our parallelogram over here. So that's saying that these are parallel. And then they're also telling us that G and A are congruent to each other. So these are our opposite angles being congruent. So that was just our given. Great. We've got that. Now it's saying that GNT is congruent to ANT. GNT. So they're saying that this angle is congruent to ATN, this angle down here. Oh, wait, that, if I just do whop, 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 that is alternate interior angles. Whop, whop. So this is kind of our N and our T. Those are alternate interior angles. Those two have to be congruent. Okay, so that's what's going on there. And then, oh, we've got this side in the middle. Thanks, reflexive property. Those two have to be the same. So that'll give us an angle, side between our two triangles. So this one's angle, side. Get that marked. Let's mark up what's going on with this stuff. So this thing that we just did, that was alternate interior angles. Then we also did our good old reflexive property. NT is congruent to NT. That's our reflexive property. And that makes those two triangles congruent. So if I follow my angle, side, I would say triangle GNT has got to be congruent to triangle angle, side, ATN. Okay, now the thing that we were trying to prove in this thing is that opposite sides are congruent. So NG and TA. NG, this one right here, has got to be congruent to that one down there. Well, they got to be because they are NG, AT. They are in the same relative spot, so that makes them congruent because they're corresponding parts of congruent triangles, which have to be congruent. That is it for this lesson on CPCTC, which is corresponding parts of congruent triangles are congruent. It is a great tool at the very end of a proof, getting that fourth pair of parts. After you prove three things, you get the triangle, and then you can just slap on this CPCTC, and you can say any corresponding parts of the triangles are congruent. Thanks for watching. Bye-bye.